She just wants to be beautiful. She goes unnoticed. She knows no limits. She craves attention. She praises an image. She prays to be sculpted by the sculptor. Oh, she don't see the light that's shining deeper than her eyes can find it. Maybe we made her blind, so she tries to cover up her pain and cut her woes away. 'Cause cover girls don't cry after their face is made. But there's a hope that's waiting for you in the dark. You should know you're beautiful just the way you are. And you don't have to change a thing, the world can change its heart. No stars, see you're beautiful. We're stars and we're beautiful. And you don't have to change a thing, the world can change its heart. No stars, see you're beautiful. We're stars and we're beautiful.
Good morning, APA, and welcome back to your first full week in school. This week we're going to be focusing on future innovations. Science Week is looking at innovating for the future. An innovation is an idea that has been transformed into practical reality. In this assembly, we are going to look at innovations that have happened in the past, those that are happening presently, and those that may happen in the future. And we're going to also have a look at some of the attributes needed to work in STEM careers. STEM focuses on science, technology, engineering, and mathematics. This week's quote is a humanist quote. The only possible basis for sound morality is mutual tolerance and respect. Tolerance of one another's customs and opinions, respect for one another's rights and feelings, awareness of one another's needs. It is especially important as we come back to school that we think about the community in APA and the community around APA. We must have respect for each other's opinions and customs, and we also need to be aware of other people's needs. We don't all have the same needs. So we need to make sure we are championing those rights for everyone. We are putting human beings and other living things at the centre of our outlook and making sure that we leave our planet in a way that helps with the future. As mentioned previously, STEM stands for science, technology, engineering and mathematics. Many of you will probably have some of these attributes already. An attribute is a feature or skill that an individual has. And there are specific attributes that help in STEM careers. Pause the video and think about any skills that you think might be needed to be a scientist. Hint, there are 15 attributes linked to STEM careers. So some of the attributes for a STEM career are curiosity, being organised, and being creative. These three attributes in particular aren't just specific to STEM careers. They are three attributes that we want to see in all subjects to make all of you better learners. We need to make sure we're being organised, having all of that work that we did during lockdown and making sure we have that now. Being curious about what we're learning, asking questions and answering questions, not just taking everything we're told for face value. And being creative, using our own ideas and our own innovations to progress. Some of the other attributes that are very important are resilience, being committed, hardworking, open-minded, okay, not just having your own viewpoint, okay, looking at the wider picture. and observant. Okay, looking at what's going on around you and trying to think about why that might be happening. This year's focus is on innovating the future. An innovation is an idea that has been transformed into practical reality. This could be a new method, an idea, a product, a process, a machine, or a business concept. Think about some of the innovations of the past. In the last century, these were some of the inventions. Radio, television, antibiotics, something we take for granted. Okay? Most of the antibiotics that we have currently have only been discovered in the last 50 years. The personal computer, the aeroplane, nuclear power, the submarine, and surprisingly the internet. Something that we heavily rely on now. Some of the innovations of the present. In this century, the 21st, these are some of the inventions so far. 3D printing, touchscreen glass on your phones, the Mars landing craft called the Beagle 2, graphene, a very important substance that has a high thermal conductivity and high electrical conductivity, which makes it of great use in most of our technologies. The Falkirk wheel. Social media, something a lot of us rely heavily on. 3G, 4G, and even 5G. 3D printing. You'll see in the video later that it can actually be used to make food. Okay, so hopefully kind of solving some of those issues that we have around the world in terms of there being not enough resources for everyone. And also 3D printing can actually be used and is being looked at being used for the development of new limbs for those people that have lost parts of their body in war or through accidents. So the possibilities are endless. Innovations for the future. Have a think. What new innovations do you think could happen in the future? In your lifetime? Some of them include energy storing bricks, artificial neurons that carry our impulses, okay, but those in silicone chips, so something that you would find in a computer, sweat-powered smartwatches, heart monitoring t-shirts, cancer detecting smart needles, so if we detect we can treat earlier, self-driving trucks and robotic guide dogs. And I know that already there's been some cars that are self-driven. Some of the other innovations for the future. Floating farms. Okay, as we run out of land, we might have farms that are raised up. Brainwave passwords, so the ability to store those passwords all in our brain without having to write anything down or store anything anywhere else. Everything will be kept in our heads. And coffee-powered cars. Okay, recycling and using the resources that we have, rather than burning those fossil fuels and causing more damage to our climate. The possibilities for future innovations are endless, and all we need is an idea. An idea that is held in many of you. And we need to start thinking and using those ideas to push further. We're now going to watch a short video clip on the future of food, so man-made meat. Scientists have found a way to use cells from animals to actually generate this meat instead of the normal processes that are used that give out a lot of carbon emissions and also use a lot of energy and land. So hopefully this is going to be a more ethically sourced production of meat.
The meat of the future will likely be lab-grown. Compared to our conventional methods of getting meat on the table, lab-grown meat, which debuted in 2013, doesn't involve slaughtering of animals, nor does it require as many environmental resources. Compared to other livestock, raising cows require 28 times more land and 11 times more water. The World Wildlife Fund adds that beef production drives 25% of global land use and forestry emissions. And in the near future, lab-grown meat is going to be cheaper, faster, and more environmentally friendly to produce for our growing population. But how exactly does one grow meat in a lab? The process isn't as weird as you might think. Currently, the most successful method involves harvesting stem cells from cows. Stem cells are the building blocks of essentially everything, from muscles to organs, from which muscle tissue is harvested from the live animal in what is said to be a harmless, painless procedure. The tissue is made up of muscle and fat cells, which the scientists separate from one another. What we need are the muscles, which are then dissected and cultured. Cell culturing is where a cell is removed from a plant or animal and then put into a favorable artificial environment, usually some type of substrate that supplies essential nutrients like amino acids and carbohydrates to grow. All it takes is just one singular muscle stem cell to grow up to 1 trillion muscle cells. The newly grown muscle cells naturally merge together to form tiny myotubes, which are then placed in a ring. The muscle cell's tendency to contract frequently causes them to grow into a small strand of muscle tissue. The muscle tissue tubes are then layered together to form a hamburger shape. One muscle cell has the potential to turn into 1 trillion muscle tissue strands, which is a lot of burgers. The lab-grown hamburgers don't quite look like normal hamburgers and are much paler in color and blander in taste. But as scientists point out, that blander taste is a fair trade for an efficient way to create protein and feed the world's growing population. The price of lab-grown hamburgers has already dropped from $325,000 to just over $11 per patty. While it is still pricey compared to a Big Mac, which costs $4.79 on average, the price will likely drop in the future as production methods are streamlined, meaning that more likely than not, lab-grown meat will be on your dinner plate in the near future.
So to conclude our assembly, remember the possibilities are endless and all we need is an idea. And that idea starts with you. I'm going to finish with this quote by Arthur C. Clarke. The only way to discover the limits of the possible is to go beyond them into the impossible. We have to break through the barriers and go through what is a difficult process in order to push past those limits and find out what is possible. Have a good week.